Okay, so as I was saying, on part B, number 12, you would do this. Take the square root and now simplify this, okay? Anytime limit goes to infinity, you find the end behavior of the rational function. The next one is, again, what you have to think about what rule you're going to apply here. Is it going to be a product? Is it going to be a quotient? But along with product or quotient, you also have, well, I think this is quotient. You have to also do chain rule. When you take derivative of the top, make sure you understand that this is a chain rule, because you have sine of not x but 4x. This one I want you to be very careful, number 13, because I specifically said use the definition. Okay, so make sure you know what the definition is. The definition is f of rise over run. By definition, derivative means slope. F of x plus h minus your y2 minus y1 f of x divided by h, because x and x cancels out, because it's x plus h minus x and x cancels out, and h goes to 0. So I want you to use this definition. Make sure everywhere you see an x, you plug in x plus h. So f of x plus h, I want you to think about what that would equal to. What would you replace x with? And f of x plus h, whatever you get for f of x plus h here after you plug in x with x plus h, that's what you're going to put in here. F of x is pretty easy to plug in because it's given to you. F of x is 3 over x. Okay? So, watch out for it. And then you would have to use the common denominator method. I hope you remember how to find common denominator. So make sure you know how to do the common denominator. Number 14. Let's look at number 14. It's one of those velocity problems. So I gave you the distance. To find the velocity, you got to find the first derivative. To find the velocity at t equals 10, just plug in t with 10. When is the particle at rest? Alright, particle at rest meaning you're not moving, meaning your velocity is not moving. So you got to set your v of t equals to 0. So after you find f prime t, meaning your derivative, set f prime t equals to 0, not t equals to 0, f prime t, the function equals to the velocity. Let's just say velocity. Substitute velocity with 0, and velocity is obviously going to be the derivative of that. So set that equal to 0, velocity function equal to 0. Once you set the velocity function equals to 0, you can solve for t. I hope you know how to find the velocity function out of it. Because I said you have to take derivative. One is the particle moving at the positive direction, and one is the particle moving at the negative direction. Once you set the v equals to 0 and you solve for t, one of the answers is going to be negative and one of the answers is going to be positive. So use the positive answer to state when it's going to the positive direction, and use the negative answer from part C to find out when it's moving at the negative direction. Like I said, once you set v equals to 0, your velocity function equals to 0, and you find your time, you will find two time, because this is going to be a quadratic equation. One of the time is going to be positive and one of the time is going to be negative. Find the distance traveled during the first 5 seconds. Again, think about what they're asking you, distance or velocity, and what are they telling you time is equal to. So this is probably the easiest question, which is part F. Find the distance traveled during the first 5 seconds. So they're not asking you for velocity, they're asking you for the distance, and this is the distance function. So f of t is the distance function, f prime t, your derivative, is the v function, velocity, and f double prime, which I'm not asking you in this question, would have been your acceleration function. So know when to use what function. If they say find velocity at time t equals to something, you obviously have to use the velocity function. And if they say find distance, when you plug in t, you plug it in the distance function. Just read the question carefully. And if you're wondering what's going on here, again, velocity function on part C has to be set to 0, okay? And then solve for t, because it's asking when. Whenever there is a question about when, they're asking about time. Number 15, all the 15 and 16. Find the equation of the line tangent and normal to the curve when y equals to x plus 1 at point x equals 3. Okay, so I gave you x1. You got to find your y1. Okay, to find y1, plug in x1 in this equation. And you also got to find m. And to find m, find the derivative, because derivative by definition is the slope. I cannot tell you it's the same thing over and over. Derivative by definition is also in your notebook. Derivative by definition is your slope. So substitute, so find m, and that's it. And if m is a number, that's good. If it's 2x, if it's 3x, then you know what to plug in for x. But get your m from the derivative of this function of y dy dx, and then equation of the tangent line, the point slope line. Make sure you know what to plug in for m when it's normal, and make sure you know what to plug in when the line is tangent. So if it's normal, then take the reciprocal and negative of the whatever you find for m, do reciprocal and change the sign. So if your m is say 2, then your reciprocal would be 1/2, and you would also have to change the sign to a negative. So for the tangent line, m doesn't change. For the normal line, m will become negative and opposite. So make sure you give me 2 equations. Okay, same thing for number 16. The way I explained number 15, you would give me 2. Make sure you find your y by plugging in x. Make sure you find your dy dx to find the slope, and then you plug all of these in this equation and find your tangent line. And normal line is easy because it's the same thing you did for tangent. You just change the slope to opposite and reciprocal. If it's negative, make it positive. If it's positive, make it negative, and then do the reciprocal also. Evaluating limits, left-hand limit. This is a left-hand limit. So I'm going to do an example. I don't want to do this problem for you because I want you to do it. Here is an example. So if I have x plus 2 and x goes to 2 from the left, I know it's going to be, x goes to -2 from the left. I know if I plug in -2, I get 0, which is infinity. The question is positive infinity or negative infinity? The way you figure out if it's positive infinity or negative infinity is the fact that it's really not at -2, but it's approaching -2. So it's just slightly a little less than 2. So -2 from the left. So let's draw a number line. You have 1, you have -1, -2. Now, -2 from the left, this is your right of -2, and this is your left. From the left is going to be -2.1, I believe. So if I'm making a mistake, you guys correct it, because you know I do make mistakes. But this is your left, and this is your right. My left-hand side, I'm looking at, because I'm coming from the left, is I'm not at 2, I'm approaching 2. There's a difference between approaching to -2 and being at -2. So that's -2 that's negative, that's more like, how should I say it? You have, this is -1, this is -1.999, and that's -2.01. It's a very small value. So it's -2.01 plus 2. So basically you end up with a -0 at the bottom. I know 0 cannot be negative, but you end up with a negative answer, and that's why your answer is not positive infinity, it's negative infinity. The way you decide whether it's positive or negative is by plugging in a number that is slightly greater than the limit. In this case it was -2, and slightly less than, depending on whether it's coming from the right or coming from the left. And number line, as you can see, always helps. Draw the number line and you get a better understanding. In order for you to figure out whether something is continuous or not continuous, I need you to, if you have an iPhone, you know you have a scientific calculator in there. And also there is an application you can upload from the App Store, a graphing calculator, or go online, and also you can go to our website in the resource center, and you will see, I will post, it's in my e-board also. It's called Gcalc. I'm gonna post the link for you guys on the e-board, where you can use a graphing calculator if you need to graph this. If you don't have a graphing calculator, you need to check the right hand limit and left hand limit, and also you need to check your graph to see if there is a cusp or if there is a corner in the graph, to figure out whether it's continuous or not continuous. And also you also got to check for B, you also got to check whether you can factor the top and cancel things out and see if you can remove the discontinuity. because you know it's going to be discontinuous at -1 in this problem, but is it possible to remove it is the question. So factor and see if you can cancel out discontinuity from it. Okay, watch out for the absolute value. You know absolute value of x plus 2 is x plus 2, so you have to have two functions. Watch out, the other one is going to be -x, -2. So make sure you know how to break it up like this, and then determine at what point it's discontinuous, both of the functions. Well, it's the same function because it's absolute value. One of them is -x minus 2. So just be careful with that. Again, you are back to right hand limit and left hand limit on number 19. So make sure you're plugging in values from the right. Well, no, it's not right hand limit and left. These are factoring problems. I'm sorry. Again, you're back in limits. This is a factoring type of problem, so make sure you know how to factor 1 minus t squared. So it's the same thing as 1 squared minus t squared. Use the formula a squared minus b squared. When you factor, it should look like a plus b, a minus b. So make sure you know how to factor it like this. So this is a, this is b. So a plus b times a minus b. I'm not going to say anymore. See if you could cancel it out, and then you can plug in -1. Complex conjugate of this square root of 1 plus 2x minus 1 is what? Think about it, because I did an example. And over here you have to, if I were you, I would take the derivative of the top, and I would take the derivative of the bottom. Okay, so take the derivative of the top and take the derivative of the bottom, and then plug in y with 0.